Okay, today we're looking at this problem. So the question asks us to solve for x, and to get x here, we'll observe that this is 3 raised to power x. So we'll write this 9 raised to power x in terms of 3 raised to power x. So this becomes 3 raised to power 2 is 9, right? Then raised to power x, then minus 4 times 3 raised to power x plus 3 equals to 0. So from here now, we can switch the two powers here. Bring this one outside, bring this one inside. Does not affect the multiplication because multiplication is commutative. Minus 4 times 3 raised to power x plus 3. So at this point, we see that 3 raised to power x is common, and we can say let's 3 raised to power x equals to p, for instance. So this becomes p squared minus 4p plus 3, and this turns out to become a quadratic equation which we can solve by factorization. We can see that the middle term is minus 4, and being minus 4, you can easily split it into 2, minus 1 and minus 3. Because we have to split it into two numbers such that the multiplication of that number will give us 3 times p squared, and the addition of the number will still give us this minus 4, and those two numbers are minus 1p and minus 3p, which if we multiply together becomes 3p squared, and if we add together it will still be minus 4p. So that becomes p squared minus 3p minus p plus 3 equals to 0. And now that we have this, p is common, we can bring out p from here, so it becomes p minus 3, and this becomes, if minus 1 is brought out from this, it becomes p minus 3 equals to 0. So p minus 3 is common, we also bring it out, and p minus 1 equals to 0. So where is this one coming from? This one is coming from here, but that's minus 1, which is common, is what we are now bringing here. Okay, so p becomes equal to, let's say p minus 3 equals to 0, or p minus 1 equals to 0, and from there p is equal to 3, or p is equal to 1. So what is p? P is 3 raised to power x, so it is equal to 3 here, and 3 raised to power x is equal to 1 here. Okay, so this 3 raised to power x is equal to what? 3 raised to power 1 here, and 3 raised to power x, 1 is 3 raised to power 0, right? So from here x is equal to 1, x is equal to 0, because here this 3 is going to cause this 3, this is going to cause this, because when the bases are equal, the powers are equal. So the entire solution to this equation, x is equal to 0 or 1. So that's the solution to this equation. Are we clear with this? Okay. Okay, so we want to look at this example. We are asked to solve for x. As we can see from this equation, the common base there is 5, so we try to express it in a way that will separate 5 raised to power x out of that equation. And from the first term here, This can be expressed as 5 raised to power x. You separate the two numbers, so that is the letter and the number, that is x and 2.
Can I write it on a
minus
paper?
5 raised to power 1 according to law of indices times 5 raised to power x, right? Plus 6 equal to 0. And from here now we've been able to see that the 5 raised to power x is common, so we say let's k equals to 5 raised to power x, so that this becomes k squared minus 5k plus 6. So this expression now has become a quadratic equation that we can solve using the method of factorization. Now what we do next is what? We try to split the middle term into two numbers such that they are factors of 6 and k squared. When we multiply them, we're going to get 6k squared, and when we add them, they will still give us the middle number, and those numbers are minus 2k and minus 3k. So this becomes minus 2k minus 3k. These two numbers, when we add them, we'll get minus 5k, but when we multiply them, it's going to give us the multiplication of these two numbers, and that's 6k squared. So k comes out of this expression. We have k minus 2 here, minus 3 is here, it's common here, and this becomes k minus 2. So you know that in quadratic expression these two brackets must be the same, otherwise something is wrong. Okay, so they are common, bring them out, and what is left, put them in a bracket, k minus 3, so equals to 0. So at this point we know that k minus 2 equals to 0, or k minus 3 equals to 0. So k is equal to 2, or k is equal to 3. So this is k. But what is k? As we see earlier, k is what? 5 raised to power x, right? So we now put here 5 raised to power x is equal to 2, or 5 raised to power x is equals to 3. Okay, now if you look at this expression, we see that we are looking for x, that is what we're looking for. So we just introduce log to both sides. You know, that's a simpler way to be able to get this expression. Yeah, so introduce log 10 to both sides, log to base 10. And here also we do the same thing, log 5 raised to power x equals to log 3. Okay, so from here becomes x log 5 equals to log 2, and here x log 5 equals to log 3, and from here we divide both sides by that's log, and x becomes log 2 all over log 5. Here x becomes log 3 all over log 5, and according to the law of logarithm, this can be written as log 2 to base 5, and this can also be written as log 3 to base 5. Okay, so these are the two values of x. So the two values of x are log 2 to base 5 or log 3 to base 5. So these are the values. Okay, that's it.